One of the image processing concept that we use is the Fourier transform. Fourier transform is nothing but converting the time domain signal into frequency domain signal. So the advantage of the frequency domain signal is that sometimes in time domain we don't see the part of the frequency is coming from, or say for example in your setup there are some noise coming from the normal electric power, that means that is 60 hertz noise. From time domain signal you will not be able to tell that there is a noise, but if you segmentize, if you analyze the time domain signal into frequency domain signal, you will be able to tell that your signal has the 60 hertz noise. So that's the goal. So now normally if we do the convert from time domain to frequency domain, so say for example we have a sinusoidal wave with say some DC component with it, say sinusoidal plus DC. So this is the DC component. Then if we do the Fourier transform, then Fourier transform has two parts. One is the real part, another is the imaginary part. This is the real part. We'll see where the frequency is positive, say here frequency are negative. So say this is the DC component. Usually DC component we see at the frequency equal to 0. So where f equal to 0 we see the DC component. Say our sinusoidal signal has 50 hertz frequency, so we will see one peak at 50 hertz and we will see another peak at minus 50 hertz. Say the length of the data vector that we are using is a total 201 points. So here is the 201 points. Now one thing to notice is that if we do the same analysis using the MATLAB, there is some changes. All the MATLAB start from 1, like MATLAB index start from 1, it cannot start from 0. So, and also another thing is that it cannot show the negative frequency, like you cannot have a negative vector index. So the way MATLAB is stored the frequency domain data is that it will store the DC value at point 1. So DC value will be at point 1. Then if we shift, think about, like if we say first think about that we have only the positive part from 0 to 101 points of data. Then if we shift all the points, say DC point at 1 and all other points, so it will move up to like this. Here is the 1 corresponding to this 0 point, this is the point 1, this 50 will come to here as a 51, this 100 will come here as a 101, so something like that. Now one thing that's to mention that what about the negative part here? What about the negative part that we have, that's from say minus 1 to minus 100? So it will wrap up inversely, something like say this minus 100 point will become here and become as a 201 point. What about this 50? This 50 will be written something like that, 151 points. So that's the way MATLAB write in the vector. Now say for example we want to remove some of the signal, say we'll use the low pass filter, and the cutoff frequency of low pass filter is, say for example, is 60. So say for example if we go here, say if you want to remove the 60, if you consider only positive part, say this is 60 point here, and we will remove from here to all other frequency. So here actually we are removing from 60 to 101 points. Now what about the other part? So other part Now in MATLAB, other part will start from 200 or 1 point. So that's corresponding to minus 100. So you can do two ways. One way to think about is that, so you are taking 101 points. So you have to take the similar point from this side, say corresponding to 60. What will be the point of corresponding minus 60? So this is 60, and so there is one point that's called, say, minus 60. So we have to figure out corresponding point of minus 60. That's the goal. So if you notice that the DC point start from 1, so, and here is the 200 or 1 points. So one way to think of that, say here how many points, 60 to 101, number of points is 41. So here number of points is 41. So, and this data is from last point 101 and starting to 60. And this signal, you can think that if you consider that this is coming from this way, then 102, here 102 points is the last point. So you can think of another way, that from 101 points we are going left up to 60. So here similarly we can go from 102 points toward the negative 60, so, or the equivalent of negative 60. So here is total 41 points. So if we go from 102 to another 41 points, that becomes 143. So that's the way to think of. Another way we can figure out like how we actually find the 143 points. So another way to think of, say here you have number of points, so 201, right? So 201 is the last point. Now if you wanna get the let the last, like the starting point here, so how much is your cutoff frequency is 60. So 101, if you minus 60, then you will find 141. So to have 143 generalize, if I generalize things, we can add 2, so then you will find the starting points. So you can use this rule in later on for all the calculation. So these are the basics, that these are the way actually you can calculate that what will be the your frequency range. Say for example, I will show one data. Say you have two sinusoidal signal, one with 50 Hz, another with 220 Hz, and your data length is 100 and you are sampling at 100 frequency. So now this is the way to do the Fourier transform. You can transform the signal into Fourier domain. Now if we look at the data, this is the time domain data. We don't see anything because this is the combination data of two sinusoidal with 50 Hz and 220 Hz. Now if we look at the frequency domain, we can see, so this is 50 Hz data and this is 220 Hz data, and this is the negative part of the data. Now if we convert, this is just one way to show that what is the frequency. In frequency domain, if we actually see in frequency domain, we will find 49.8, that's 50, and here is 220. Now if we remove, say we want to remove anything above 80 Hz, if we do the filtering that one, so we will find this kind of data after removal. So or if you say that we wanna remove anything less than 80 hertz, so we are doing that. We can do the opposite thing too. So the way you will save or way you will remove the data, you can do that. That depends on you, how you wanna save the data or how you wanna remove the data. Important thing is that, like here you have to define like which frequency range you are trying to remove and which way you wanna remove. Thank you.